Okay, so for this one, we're gonna break up the function so that once we figure out all the prime numbers, up to 1,000, 1,210, 10,000, once we figure out all the prime numbers, then we can sort of loop through each prime number to figure out the even digits, basically. So since I already wrote out the sieve of E algorithm here, so we're gonna take that code okay, we're gonna switch this out, and then we're gonna take n here, basically, which is this end up here. Alright, so now this figures out all of the prime numbers for us, and now we're gonna find out which one are even. So with that in mind, we're just gonna set a variable highest, or a tracker, even prime num equal to 0. And then we're also going to set up the length, basically, to keep track. So as the numbers get higher, we can sort of know if three of them are even, then we should only keep track of E as they get higher from there. So we're going to call it even length equal to 0. With that in mind, we have to set up a variable called var prime num. These are all the prime numbers, and then we loop through each prime. Basically, it's an array. So basically, this sort of looks like 2, 3, 5, and such, you know. But they're actually strings here, so they're actually more like this, and such. So when we loop through them, we can use a for each statement, basically, for each to loop through, and we're just going to call it each one that we're looping through elements. Declare our function here. So let's see, let's just close this out before we forget. And then the way I know of it, simple way, is to use regex. So I'm going to set up a pattern equals to, we're going to set the global variable, so it finds all of them, and then find each character, which is 2, 4, 6, 8, 0 from there. So basically all the even numbers we're going to look for in each element. So from there, it is also possible that each element isn't, or each prime number, all of the digits could be odd. So basically, if it's odd, then we might have a problem. So this is what we're going to run. Let me just write it out so I can explain it better. If element, which is each prime number, dot match this pattern, close it out. So element dot match pattern dot length. So this equals to the even count. So we're counting how many. So let's say we're up to this prime number 887. Or actually, let's say, yeah. So 887 is actually good. So we're up to 887. What happens is it's gonna find how many patterns in here? It's gonna find 2. So basically, in the regex, when it finds it, it's gonna be 8 and 8. This is what this pattern matches. So it basically matches 8 and 8, and it gives a length of 2. So with that, we can sort of keep track of even length. So basically, if we were to do, let's say, 2, then it just equal to, well, let's just keep this separated. So we just do 2. Basically, you just have 2, and it's a length of 1. And we're gonna keep on going with that. So with that count, so basically, we're gonna keep track of it. Of if even count. So as we go higher and higher each number, as long as it's greater than or equal to even length. Actually, I should do var even count. It's greater than even length. So when we do this, then we set up the highest prime or even prime num equal to element as we go up, basically, as it increments. And then we're going to chain even length equals to even count, basically. And we're going to close out this loop. Alright, so let's say when we're going through for 1,000, when we put 1,000 here, it's going to get all the prime numbers here. This keeps track of the highest prime number, and this keeps track of the length. So as each prime number goes through each loop, it's going to take a prime number, it's going to go 2, 3, 5, and we're going to try to find the pattern, basically. So from here, we only care about all the even characteristics, and this is just a test variable. It's like the try catch, because if we didn't have this variable here, we're gonna, if a prime number was odd, let's say 3 would sort of break the code here. So when we do here and we match 2 as the first digit, as first element, we only have a length of 1, which increments even count by 1. And then if even count is 1, it's greater than even length, which starts off at 0, then we run through this loop. So every time as we increment these values, as it goes through, as it gets higher and higher even digits, then we loop through here. And here we keep track of the highest even prime number. So the first one is 2. It's 2 here, and then it just changes the 0 to 2, and as we keep track. And then here, because even count or even length was 0, now even count is 1, is going to set even length as we loop through each one. And so basically we should be, in theory, able to return the number sets of highest, even, prime, num at the end of this. So basically, this should work. Uh, 487 should be it, should it not? So okay. So here we're gonna not set it equal to the upward bound, and we're also gonna remove the upward bound, at least not equal, so we get this second to last as the highest, and then we go from there. And it worked.